and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Scott Cain.
Thank you, William. And thank you, everybody, for joining us on this Tech by KYZEN. Appreciate you taking a couple minutes of your time. Hopefully you find the time valuable and learn a little something more about KYZEN. So today we're going to be talking about overcoming cleaning challenges in AI applications. And I want to give a shout out to Jason Chan, who's our global product marketing leader out of Taiwan. Haley Reed also helped a lot on this. She's our head chemist out of Nashville. And my name is Scott Cain, and I'm the key account manager / segment specialist for advanced packaging in North America and Europe. So with the advancement of AI, what are the requirements to meet outstanding cleaning? And how do we get there? So what are we going to talk about today? Real quickly, we're just going to talk about AI, how it's come into our lives, and what's going to go on from there. As more applications are created, issues arise. Different materials, compatibility, bath life, what are the cleanliness expectations? We're going to investigate that a little bit. What are the challenges that these specific applications bring to the table? And what can be done to remove the concerns and provide a clean product that's acceptable by the end customer out in the field and by yourself? So let's talk real quick about AI. It's kind of a buzzword. Everybody's hearing a lot about it. It's really just artificial intelligence. And that includes technologies such as machine learning, some deep learning, some of the language stuff for ChatGPT and the such. And where is this going to affect? Well, it's really going to be everywhere. It's going to be in healthcare and cybersecurity. We're going to see a lot of it in the military, robotics. Education is going to be a huge part of this. It's also going to be in agriculture, and pretty much you won't be able to touch a focus or an industry where they're not figuring out how AI can be useful to compile data, produce data, so on and so forth. So with that, we've got these new devices, these AI devices, and what are some of these challenges? So let's take a look at this one. This is TMC's chip on wafer on substrate technology. Now, when we talk about a 3D IC, that's going to be building it up, whereas this is a little different. This is the 2.5D. And this is going to include some of that silicone on chip and some of the HBMs, the high bandwidth memory integration. So as you can see in the picture in the upper right-hand side, it's going to have the HBM and the SoC on the substrate with the interposer in it, and not just built up, but built out a little bit. So let's take to a cutaway view, and we look at this one, and we can see that there's a lot of fine pitch. There's low standoff gaps. There's multiple dies on top of it, and we've got pretty large sizes. And so what we're looking at, there's a lot more place for contamination to get in there. And those chips are only going to grow bigger because we're going to need more computing power. We want it in less space with less thermal issues. So there are the cleaning issues that we're seeing here, right? Again, we talk about the low pitch, the low standoffs, a lot of components, small space, a lot of places for contamination to hang out. So what are the requirements for cleaning these? As always, whether we're cleaning a lasagna pan or some throw up off of baby Johnny's little onesie, we're talking about 4 major things that help determine if we get it clean. What is the time? What is the energy, the solvency, and the temperature? So we talk about time, we're looking at what's going on inside of the machine. And at this point, and we're going to talk about this on another screen as well, but with the machine companies, it's highly advantageous when you're trying to evaluate, benchmark, improve your cleaning process is to talk to the cleaning machine companies. What's going on with your machine? They may be able to do something different with your new machine. With your machine, they may have new parts that they can add to it, something they've seen in the field, optimization of the nozzles, the speed, how long it's sitting inside of it. So highly advise having a conversation with them. Part of that as well is what is the energy? How are we creating that impingement to get into these parts and get everything out of these parts? Solvency, what's the concentration? What's the chemistry? Is it the right chemistry for the application? We'll talk about that in a minute. And then temperature. We need to know what the range of the materials that are going through, what that temperature is, what the temperature that the machine can handle, what the temperature of the chemistry. All of those things need to make sure they're all within the same range, so we're not affecting the part that's going through or not getting the efficiency that we're looking for from the chemistry. So one of the things when we're talking about the cleaning machines for when we're cleaning on substrates, we need to make sure we have the cleaning mechanism optimized. We need to understand what those nozzles are, how they're angled, and if we have enough time in there. Now, on the right-hand side, we have both the inline spraying layer and the batch spraying layer. Almost all of these applications will be done in an inline spraying layer, but we want to make sure those nozzles are angled correctly, have the right kind of pressure, the right kind of spray to get into those components. Both your chemistry cleaning company and your machine company can assist with this and kind of running some trials on both of those. Now, when it comes to the chemistry side, we want to make sure that we have matching soils. A lot of these are going to be done with water-soluble flux, but knowing what the Hansen solubility is, a lot of that is already tested. For us, for example, we work with all the flux manufacturers to make sure they can't come to market with a new product unless it can be cleaned. And we're not going to introduce a new cleaning chemistry unless it can clean what's out there in the field. So relaying that information is really important. Some other key attributes that you want your cleaning chemistry to have is a low surface tension, right? We'll talk about that on the next page. One of the things that's very important in this area of cleaning is the metal compatibility. We are going to be looking at coppers, nickels, aluminums, golds. We want to make sure that we're not going to have any etching. We want to make sure that we're going to have a completely clean surface. That's really easy to set your benchmark. If it's a visually clean surface without any etching on it, that's going to create a clean area, and it creates that standard for everything going through. Low foaming. What I always say about foaming is there's a big difference between a 5-year-old pouring a beer and a bartender pouring a beer. You're going to get a little foaming, similar to that of the bartender pouring it. You don't want to see a lot of it, considering like a little kid pouring a beer. So keep that in mind. That can cause all kinds of issues within the machine in terms of float switches and flooding and so on and so forth. And we need it to be able to rinse. It's got to be free rinsing. It is better to not wash than it is to wash and have insufficient rinsing. And we'll kind of show you that why here. So if we look at this, we've got a substrate and we've got two different components. And we can see the difference between a 3 mil gap and a 2 mil gap. So if we bring DI water in, we can see that because the dyne size is usually about 72 to 74 dyne, it's not going to get into every gap that's there. So it's going to bounce around, but it's not actually cleaning under what we're looking for. So as we can see, the DI water does not work in there. But if we utilize an engineered solution, this one being utilized at 3% concentration, that's going to get under those 2 mil gaps. So now when we talk about these materials that have the fine pitch size and the tight component places, this is going to be able to get under there for not only the wash portion, but the rinse portion of the process. So some things to keep in mind to get a completely successful properties. Benchmark your current process. Let's see what's going on in the current process. Now, what do we want to improve? Do we need to improve throughput? Do we need to improve the quality of cleanliness? Do we want to be able to reduce the chemistry concentration, or how long the chemistry is lasting? Then let's start to have those conversations with all the players that are involved in that. And one thing to make sure, and you guys are all engineers, but we want to make sure we do this, we only change one process parameter at a time. If we change multiple, then we don't know what's really having the effect in moving the standards forward towards what the requirements desire. And a successful process will have no flux residues or contamination remaining. So, in conclusion, the AI and the packaging required, it's only going to grow. And with new technology comes new challenges in manufacturing. And while that's exciting, we need to be evaluating what those challenges are and kind of how to combat them. Understanding these requirements for effective cleaning ensures the long-term functionality of these parts. Some of these go into pretty critical applications. We want to make sure we have them really clean. Working in conjunction with the machine, flux, and chemistry partners is crucial to confirm the application optimization, and make sure to benchmark as we go along. Some of the frequently asked questions that we get in this is, why is cleaning for these applications important? We're looking at reliability. We're looking at parts that last a long time. If the flux is in there, we're going to have electromagnetic migration, we're going to have premature failures, and then we're going to have to replace these. So making sure that you have a completely clean part is going to make sure not only that the applications last longer, the parts last longer, and the perceived quality of the product is increased. What constitutes a clean AI package? There's really a lot of everybody's got to determine their own cleanliness on these. There's a number of different tests that are available out there. It's really best to speak with a KYZEN representative on the breadth of products that are out there to confirm this cleanliness and figure out which one's going to work best for you. And then what about the chip on wafer applications? And we're trying to keep these short. We're trying to keep these in the 8 to 10 minute range where you can just kind of have it with a cup of coffee. And we just don't have enough time on this one to talk about the chip on wafer. What I would advise, if you've got an immediate need, is talk to a KYZEN representative. We can kind of walk through the differences on those applications. And I would also advise getting the tech-to-text sent to your email inbox, because my guess is you're going to see one of these on chip-on-wafer applications going forward. So finally, just some reminders. Hey, we're here to help. The chemistry suppliers, the machine manufacturers, the flux, this is all we know. We can kind of be an extension of your engineering department. We have labs in 4 facilities around the world where we can run a lot of these trials where you don't have to run them and affect production and affect your time. And hey, we love talking about this stuff, so we're happy to help. I appreciate you guys taking a couple minutes out of your day. And please, if there's any questions, reach out to any member of the KYZEN team.
Thanks, Scott. Thank you guys for watching this Tech and Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.